Hello and welcome to the channel. Today we are going to dive into a deep technical comparison of two foundational technologies in infrastructure engineering: virtualization and containerization. These are often used to isolate and run applications, but their architectural design and use cases and security implications differ in critical ways. Before we proceed, if you find this content helpful, please like and subscribe. Your support helps grow our community and signals to YouTube that this channel provides valuable information. I very appreciate your help in sharing knowledge. So, let's begin with the virtualization. Virtualization allows multiple operation systems to run on a single physical host. This is done through a hypervisor, which is the core component of virtualization. There are two types of hypervisors, Type 1 and Type 2. Type 1 hypervisors, also known as bare metal hypervisors, run directly on the server hardware. They don't require host operation system, which means better performance and strong isolation. Examples include VMware ESXi, Microsoft Hyper-V, etc. Type 2 hypervisor, by contrast, run on top of a host operation system. They function more like regular applications. Because they add an extra layer, they typically offer low performance and weak isolation. These are often used for local testing or developer setups. Examples include the VMware Workstation or VirtualBox. In a virtualized environment, each virtual machine runs its own full operation system libraries, application stack, etc. The hypervisor abstracts physical resources like CPU, RAM, storage, and networking, assigning them to each virtual machine in a controlled manner. This level of isolation is very strong, which is why virtual machines are used in situations where security or operation system level separation or compliance are key concerns. However, the isolation comes with overhead. Each virtual machine consumes memory and CPU to support its own operation system and runtime. Boot times are slower, image sizes are large, and orchestration can be a bit complex. This affects resource efficiency and limits how many instances you can run on a given host. Now, let's move to containerization. Containers are not virtual machines. They don't include their own full operation system. Instead, containers run as isolated processes on the host system and share the host operation system kernel. Tools like Docker and Containerd use kernel features like C groups, namespaces, and union file systems to isolate containers, limit their resources, and manage their lifecycle. This makes containers lightweight, fast to start, and more efficient in terms of memory and CPU consumption. From an architectural perspective, the biggest difference is that containers rely on the host operation kernel, while virtual machines run full operation systems independently. This allows containers to run more efficiently, but it also introduces unique security and compatibility challenges. For example, you cannot run a Windows container on a Linux host without virtualization, and of course vice versa. Moreover, because containers share the kernel, a vulnerability in the kernel could potentially affect all containers on this host. That's why it's critical to patch the host operation system, restrict container privileges, use read-only root file system, and apply runtime security profiles if it's necessary. Network isolation also differs. Virtual machines use virtual NICs, often configured via enterprise-grade hypervisor tools. Containers typically use virtual bridges and IP namespaces managed by Docker or Kubernetes. While container networks are isolated by default, achieving strict ingress-egress control requires additional configuration, like using network policies, service meshes, or firewall rules. For teams managing security, containers demand greater discipline to achieve the same level of isolation that virtual machines provide by design. When it comes to use cases, virtual machines are better suited for workloads that require a specific operation system version, kernel customization, or strong multi-tenant isolation. They are also the standard choice for running legacy applications or maybe compliance-sensitive workloads. Containers, on the other hand, are ideal for stateless services, microservice deployments, and AD environments that needs high scalability, fast restarts, and small resources footprints. Another key consideration is orchestration and lifecycle management. Virtual machines are managed through tools like VMware vSphere, Microsoft System Center, or Proxmox, for example. These platforms offer integrated backup, a snapshot, and high availability functionality. Containers are orchestrated via Kubernetes, which enables advanced deployment patterns like rolling updates, auto-scaling, and service discovery, but with additional complexity. Security is next topic for consideration. Virtual machines provide hardware-level isolation, minimizing the blast radius or potential compromise. Containers depends on the kernel, so kernel vulnerabilities can affect all workloads. That said, container security is evolving fast. Tools like Trivy, Claire, or Anchor can scan container images. Secrets can be injected securely using HashiCorp Vault or Kubernetes secrets. Runtime protection with SecComp, AppArmor, and SE Linux is also possible. Another aspect worth considering is power consumption and performance overhead. Several studies, including those published on well-known resources, show that containers consume less CPU and power under load compared to virtual machines. This makes them attractive for high-density, performance-sensitive environments. You should also consider operational maturity. Containers are a newer model and require different skills, such as Docker file writing, image lifecycle management, and Kubernetes-based operations. Teams transitions from virtual machines to containers must plan for upscaling, updating security policies, and rethinking deployment architecture. In practice, most modern systems use both virtual machines and containers. For example, cloud-based Kubernetes clusters often run inside virtual machines to combine the strong isolation of virtualization with the efficiency and speed of containers. This hybrid model is very common and often the best compromise in enterprise setups. Ultimately, the decision between virtualization and containerization depends on your requirements. If you need strong isolation, multiple operation system types, and full control over system internals, maybe you should use virtual machines. If you need speed, efficiency, and scalable microservices, go with containers. When both are important, combine them. Thanks for watching, and see you in the next video.